There again, barely showing the crosshatch. Both sides of the cutter cutting. Yeah, actually I had to brake on a little bit, and okay, I got 7 there. And I got stuff sticking up over here, so I gotta come over here a little bit. Yeah, that was really, I got 5 there. Seven there. Okay, I got probably between 6.5 and 7 all the way. I'm gonna go ahead and sneak in for like 4 thousandths here. I tell you what, that is pretty close right there. That is pretty close. I'm gonna leave it right there. Let's see what we got. I got 2 thousandths right there. I got 3 thousandths right there. 2. Probably just depends on where. I got 1 right there, but there's a little bit of flux right there, so I might be reading on top of that. That's about 2 thousandths. I'm gonna call that good, because I don't want to take and dig into this original material by accident. If it's a little bit more work physically for me to lap that in, I'm going to be satisfied with that outcome at the end. Alright, let's change out. We're going to put in a boring bar. We're going to get in here. We're going to dial this inner diameter here with our coaxial indicator. Alright, now when I'm using a coaxial indicator, I went ahead and I put it in a 3/8 quill here, brought it down, I bent this out, and I'm eyeballing the ball in relationship to the best part of the circle that I could see. So across there over to here, I can see that the actual diameter of that ball is just outside of there, so I went ahead and I cranked it over here and cranked the table so it's over in that direction. Now I have some bores in here that I want to try to get down below. So I'm going to go down to the bottom and eyeball that just underneath those bores so that I could do the full sweep right around that diameter below the holes. Okay, just rotate it around by hand. I always do this first so that you don't turn it on. And of course there's a little bit of, see right there, there's right at that hole, there's a little bit of flux right there. So I'm not going to high speed spin this here. I'm just going to go ahead and I'm going to work front and back, about halfway in between there. Okay, close. Now we'll bring this back here. Okay, now we're going to tighten up the table because and the knee, because you can you can have it perfectly in line, and then you can tighten up everything. And what you do is you lift up this table because you're sucking it into the knee there. You tighten it, so you might be shifting it here or cocking it sideways. You tighten it all the gibs up so it actually will change. And here it almost changed it back to the opposite of what I had it at just a few seconds ago. Front and back's pretty close, and just got to bring that side down there. There's 0, very close to 0. Okay, I like that. Alright, we're setting 0 on our X and Y here, because if we want to go ahead and we see that we want to come in a little bit closer to the bronze area, making sure that we're not going to sweep any of the other area there, we can adjust it and we know how much we're actually going to be moving it because we have the readout on here now. Otherwise you'd be relying on your dials. I mean, that's what you have to rely on if you don't have a readout. I had this mill for, I don't know, a couple years before I was able to swing a readout. You can't always afford to get every attachment for every machine that you have. Okay, I went over to the lathe and got my boring bar and put in here. I use it in a boring bar as well. It fits in one of my CA holders, so I do a lot of boring with it over in the mill. I don't have a whole bunch of them, so I kind of switch one around all the time. Now, I like to put this thing in free mode here, meaning I can spin it freely, so I get the feel of it. And also, too, I can put the wrench in here. Sometimes I put it in here like this, and then I can bring it right on down here, and then I can crank it out where I want. Now, we're going to be touching brass, but I want to make sure that I'm in far enough and start getting a feel for the diameter. I'm going to go ahead and lock it in. We're going to cause this to be our first pass. We're going to do this manually without indexing it first. Alright, engage our power and our feed for manual. When I touch, I'm going to set 0 so I know where 0 is at. Okay, now we can measure from here to there and know that our hole was 1 3/8 was the actual size of this hole, plus a thou we found when we machined our graphite insert to braze with. So anyway, is measuring like 1 3/20 or so. So we have about 20 thousandths per side. As you move, we have 50 thousandths per side. Let's take it on over here and we're staring down there. It's close to 50 thousandths that it's got to come out to the material there, and that's what we're showing here. Because we're 75, and we're about 320 right now is what I'm measuring across here. Now on this head here, it has a very accurate dial here. We're going to set it for 0 there. We only took about 20, so it's about 10 per side or so. We're still getting the feel of this thing. We're going to pop it up out of the way here so we can really get in here and look at it. Right there. Alright. And we're just going to check a few things here. 330 that way. I'm trying to catch new and old material here, a couple straight across directions here, just to see. 329. Okay, we're pretty close to being equal. Here's 20. That's 20. This reads the diameter. There's a diameter dial on here. And or an actual for your dimensions there. So this would be like 10,000 per side. Okay, I'm sneaking up on it, and I'm checking it back and forth, and I get in here, and this is like 348, and I do the same thing this way here, 348. We were at 338, and I took 20, which is 10 per side, and that's all we're removing is 10 per side each time, because we're only working the high spot that we're touching here. So so 48. We got basically 10, 25, 26, 27 thousandths to come off per side, and we are slowly sneaking up on it. And I take another 10 per side here. Yeah, 58 there. $58 there. Take another 10 per side. Always put your finger in there and feel the difference of the surfaces. Get a feel of it. That was the sound of taking off some of the flux that dripped down into the bore. Okay, I'm just seeing how far down in the bore we are. Okay, that's below everywhere, so I just want to mark that down. That's like 700. We're not in danger of hitting until we get to almost a little bit over an inch, so I just want to make sure we stay off of that table. That's feeling real close. I can feel more of a lip over here than over here. Our readings are still 0, 0. Okay, but now I'm going to reach on over here closer and see if I want to shift this X and Y in any one direction here. Okay, as close as I can go around here without touching that other brass right there, I've got 365. And when I go across this direction over here, yeah, like 369, 368. I'm going to trust my instincts and I'm going to crank 2000s in. Make it 3. All right. I'm not going to adjust this. I want to come down now and feel this the cut after I pass by. Okay, almost feels nil on both sides there. I'm almost feeling a little bit in here. So I'm going to crank it back. I'm going to crank it back 2. Now we're going to crank it. I want to crank it I'm going to crank it 2 that way also. There's 2. Alright, now I'm going to come down again. I'm just trying to blend this into a diameter, and then I want a round hole. is what I want, but I want to reach in, and I'd rather be touching that brass and hitting that brass than skimming the original bore. I want to keep that original bore. If I get it real close, I do have a 1 3/8 reamer, and I can actually run that through from the other side by hand very gingerly and probably peel some of that bronze out, but I want to make sure that it's real close. In fact, actually a little flapper wheel, if that makes it work, that makes it work. I can test it with my plug that I already made for the graphite plug there. We can check it out with that. Okay, now we're going to check the dimensions here. About 68. $69. That's 5 on the diameter. Should be taking 2.5 off each side. I'm skimming the brass without touching the cast iron. Skimming the flux all the way down. I can watch it go around that hole over there. It's 600 deep. Alright. I tell you what, that almost feels like we got a 1 3/8 hole here. And I'm measuring a 1 3/8 hole that way. I'm measuring about 2 under right there. I do see just a light bit of scrape on the cast iron here. Not so much right over there. I'm going to back this 1/1000 this way. Okay, I went in the other room and this still got the flux, everything else on here, and I want to, good, we have enough room. Okay, that wants to go in there. I think just a little bit of polish in that bore and I'm going to be good. So I'm done with this. I'm happy. Look at I've got that brass all the way out to the bore, all the way where we scalloped it. Got a nice sharp edge up here at the top. We're going to have material all the way around the hole so we don't have any voids in there. And we don't have any stress rise areas that's going to want to be a weak point of pulling this away. The braze will be secure enough in this part here to operate as it has been for its whole life already. It still won't, I'm not going to guarantee it. If you were to try to knock this out without pulling those wedge pins out again, you will do damage to it, okay? But for operation of this lathe and the compound and holding it secure, this is going to be a good repair. Alright, I'm going to go ahead and run my bit through here while we're holding it in this position here, if I can get one in here. or a 5/16 reamer if I have a long one. I'm going to see if I can do that, and then we're going to go ahead and lap, and we're going to polish out that bore, and we're going to see what we can have for a finished product here. Alright, we found a 5/16 reamer long enough, I believe. If we choke this up, we'll have clearance to the table here. Real. I don't anticipate very much effort to go into this because it really was barely inside there. So, alright, there's up to it. Back it up just a little bit. Oh, it's a nice. Okay. There was even less debris in that one. Alright, I believe we're ready to pop this thing loose now. And then we can hold it up to the light and actually get to see a little bit, and we can run a polish right in around these holes here. Lap the top of this, lap the bottom of it. And Timothy's gonna have a part to put back on his lathe. Been so long, I really apologize. Oh yeah. Let's see, can you... Here's that one. Alright, we just used some of this Duro all-purpose spray. This is a pretty old can, and it's pretty hard to get it to come out and shake it. And anyway, we spray the back of the paper, spray the top of the stone, and then we get to stick on there really good. And we make sure that it's going to hold still, because we're going to probably be putting a little bit of firmness into our polish here, and we want to make sure that it is the best quality as possible. Alright, now we figured that we got about 2/1000ths on here, so I'm going to do a quick little rub there, and we're going to make sure that we're working on the brass and kind of getting an idea of how much we're actually working off of each end there as well. Make sure nothing like getting a piece of grit in underneath your paper or underneath your part when you start out. Also, hold it lightly until you know that you're breaking it in a little bit. Getting that rough, you can see a couple little scrapes and scratches right there. Alright, every bit of that brass is getting a crosshatch on it. Try to push the load in the center there so that you're not forcing one or the other end here. Coming nice. A little light touch here. You can see a little bit out here, but we're working that area right there. So, and it's starting to come in. You see a little bit more out here, but it really is taking that down. Rotate your part around so you're in a little different direction. I can see the brass in the paper starting to fog in a little bit more. See, now we're starting to hit the cast here. Starting to hit the cast right around that worked on area there. Really nice. And there's our 0 mark and the line. We don't want to lose that. Okay, we're going to get the air nozzle, blow out our paper. Coming in nice. We're almost, you know, I'm not going to give too much more because we are down there where I rotary burred that out to the edge there. Quite didn't fill in all the outside there, but that's not going to affect the operation of it. Still got the 0 there. Okay, I'm going to hit a little bit on the underside here. Now that we got firm paper here. And you can see the light pickup starting out here. Okay, any other work from here on out, Timothy can work that. I'm going to get in here and just lightly paper this so that I know that he'll be able to drop his compound right into this carriage cloth side. And then I'm going to run the tap through his holes here and here, making sure that all the thread passages and even the 3/8 here and here are free of any flux. This is no more than just a cleaning out, so it's not like you're forcing or having to cut any teeth, or threads I should say. I do get some you can smell it's like burnt oil down in there. It's tapped down to where almost maybe a ½ inch from the actual bore, so that that pin has nothing but straight diameter down at the bottom there to engage that angle or dovetail on the end of it. Okay, and I believe these look like 5/16 tapped in here, and I really don't know what those are for. I'm going to go ahead and get the tap in the handle here so I have a better feel. Might have been some kind of attachment that they had mounted on here, or a milling attachment maybe was what somebody fixed this up for. Because if you got these two straight in line there, you could probably put a nice angle plate up here. Okay, now I gotta go get the screws because I think those are were 1032, something like that, coming in on the side here. Alright, I got over the toolbox and I was trying to size up the thread here, and I thought it was, at a glance I picked it up and I go 1032, and that's pretty close to a 1032, but it's a little bit larger than a 1032 and it's a little coarser than 32 thread. Okay, it's a 28 thread, which is our standard 28 thread is a 1/4 inch. But back in the day that they made these lathes, 12/28 was a very common screw size. And of course I may have one, but I searched and I searched in my drawer and I couldn't find one quickly. So, you know, I says, hey, when we went through Lalore's toolbox, there were some oldie taps in there, and I put them all in a little box, and I just went and I grabbed the box and I just went digging through there and everything else. And this is it is a 1228, and it's made in the USA. And I'm trying to look at the brand here, and it looks like Greenfield. All right. So anyway, it's got a little tiny bit of rust and everything else on there, and it is a right hand. Some of the taps he actually had in there, where he had like a 1/4 inch left hand and things like that. But I actually have one, and just kind of reminded me a little bit about Lalore's toolbox there, and we get to think about him a little bit more, a little longer. Thank you very much, Lalore. And we can go ahead, come in here, and correctly chase out the Gibbs screws. Some of that rust and dust may be coming out of the burnt oils and stuff out of the hole, but some of it might actually be coming off of his tap here. Alright, so we're going to finish cleaning out the rest of the holes here, and then we got to find this box and get things together, and we'll collect it up and go in the other room and finalize the video here. I think it's got a happy ending though. Alright, just got off the phone with Tim and gave him the news there that I finally got around to it, and repaired his slide for his carriage and compound on his lathe there. He did say that he picked one up on eBay or whatever, and he's been using it to get by while I've had this one, and it's not quite the same fit, and he's really racking his knuckles and stuff on the small handles, he says. But anyway, I just got off the phone with him, and of course, like we talked about, Tim, you just take a look at it, put it on your lathe, get it going, and just drop something in there on my sponsorship there. I apologize again for how long it's taken me to get the job done. I'm also going to throw in a ball cap for you, and we're going to get that made up and on its way to you. We touched base a little bit on creating turned graphite dams, is the best way to put it. And this works real well with brazing. If you're working aluminum, you can use copper, or I also use steel. And if this was all aluminum and I was really doing this, I would just turn some steel, and I have good results on welding aluminum right over the top of steel, and puddling it right on there and flipping it over and just sealing in the little folds and stuff where the lap actually cools down a little bit right next to the part. I also have flat, and you've seen in a couple of my videos there with the steady rest repair, you see me use the flat, and you know, you can always clamp that right underneath, and you can puddle and braze right out on a flat surface. So those are a couple ideas on brazing, and I choose braze because you see how well it finishes. By using the dam, I was able to keep those holes. Nothing worse than trying to come in, even if it's soft material, come in and try to get half of a hole. It's a lot easier if you dam it, where you just got a little minute amount to clean, and you saw the reamer and the drill, it just goes right in there. No problem. So until next time, get her done.